Welcome to G Fun Facts Online. Have you ever stopped to think about what makes the simple act of breathing possible? You might think of trees and photosynthesis, and you'd be right. But the story goes much, much deeper. It stretches thousands of kilometers beneath your feet, down to the fiery heart of our planet. Because the oxygen in our air is fundamentally linked to a colossal engine of molten iron churning ceaselessly at the center of the Earth. Today, we're talking about the invisible, life-sustaining force field this engine creates, our planet's magnetosphere. It's a profound connection, from a metallic core to the air that fuels all life as we know it. So, how does a planet become a giant magnet? Our planet's core has two parts, a solid inner ball of iron and nickel, and a liquid outer core of molten metal surrounding it. The incredible heat and pressure keep this outer core in a constant churning state of motion. Imagine a spinning sphere of electrically conductive liquid iron. This movement creates massive electrical currents, a process known as the geodynamo, which transforms the entire Earth into a giant magnet. This magnetic field is not some static, unchanging thing. It's a dynamic entity, constantly shifting in strength and direction. Scientists map these changes using a field called geomagnetic cartography. They use constellations of satellites, like the European Space Agency's SWARM mission, to take precise measurements from orbit. They also study data from ground observatories and even analyze ancient rocks, which act like geological time capsules. These rock records show the magnetic field has been around for at least 4.2 billion years, and that it has fluctuated wildly, with the magnetic poles wandering and even completely flipping numerous times. The primary job of this magnetosphere is to be a planetary shield. Earth is constantly being bombarded by the solar wind, which is a stream of charged particles flowing from the sun. Without our magnetic shield, this solar wind would slam directly into our upper atmosphere, stripping it away over time in a process called atmospheric sputtering. This protective bubble deflects the vast majority of these particles, safeguarding our precious blanket of air and, crucially, our water. If you want a chilling example of what happens without a magnetic field, we only need to look to our planetary neighbor, Mars. Evidence strongly suggests that Mars once had a thicker atmosphere, liquid water on its surface, and a global magnetic field just like ours. But about 4 billion years ago, the Martian core cooled and solidified. Its geodynamo shut down. Without the protection of its magnetosphere, the solar wind began blasting away the planet's atmosphere. Over millions of years, Mars was transformed from a potentially habitable world into the cold, barren planet we see today. The fate of Mars is a stark reminder of how essential our magnetic field is. This brings us back to oxygen. The story is surprisingly complex. For the first 2 billion years of Earth's history, our atmosphere was pretty much oxygen-free. That all changed with the Great Oxidation Event, when photosynthetic cyanobacteria began producing oxygen on a massive scale. To get this process started, a strong magnetic field was essential. It acted as a protective cradle, shielding the early atmosphere from erosion and allowing that newly produced oxygen to accumulate without being immediately blown away into space. But here's a fascinating twist. Recent research suggests that a period when the magnetic field became extremely weak may have actually fueled a later explosion of life. Between 591 and 565 million years ago, the field weakened to its lowest known point, about 30 times weaker than today. This near collapse of the shield may have allowed more of the lightweight hydrogen gas in our atmosphere to escape into space. The loss of hydrogen resulted in a higher relative concentration of oxygen, which may have fueled the evolution of the first large, complex animals. And looking at the last 540 million years, scientists have found another strong correlation. The strength of the magnetic field and the percentage of oxygen in the atmosphere seem to have increased in lockstep. Today, satellites continue to map our magnetic field with incredible precision, revealing a dynamic and restless system. One feature scientists are watching closely is the South Atlantic Anomaly, a huge region of weakened magnetic field strength that stretches from South America to Africa. You can think of it as a dent in our magnetic shield. Now, this doesn't affect life on the surface, but it is a hazard for satellites and spacecraft, including the International Space Station. When they pass through the anomaly, they are more exposed to high-energy particles from the Sun, which can cause electronic glitches and even permanent damage. The intricate dance between the Earth's molten core, its invisible magnetic shield, and the air we breathe is a fundamental story of our planet's habitability. It's a connection that made the rise of complex life possible, and one that continues to protect us every single day. The simple act of breathing is, in a very real way, tied to the immense and ancient power churning at the very center of the Earth. Thanks for listening to Fun Facts Online.